Welcome again to the second part of the revision, where we will talk about week. Just let me get the full screen. Okay, we'll talk about week 3 and 4 together because they both discuss the same topic. Talk about the relational model. Okay, very important topic, or very important 2 weeks, because they will set. They are still these 2 weeks are still a kind of introduction, but they will set very important understanding to what's coming later in your database. So it is very important that you understand this topic very well, because again it will set the basics. So we'll talk about the relations, العلاقات between the tables of the database. Right. So we'll discuss a few terminologies, very important terminologies in these 2 weeks. Well, first of all, we have this term attribute. Okay. Now attribute خصائص. I think we studied this earlier in Java, but in the database it's applied maybe in a different way. And we have also tuple. Okay, that's another terminology that is important. Now, if you consider, for example, I'll draw just a quick table. If we have a table that contains ID, name, maybe department, and so on. Okay, that's a table. Okay, we know that these represent rows and these represent columns. Now, it's another way of saying attributes and tuples. So, every column is an attribute. Okay? Every column is an attribute. And every row is a tuple. Okay? This is very important that you be aware of, that an attribute is a column, a tuple is a row. Also, as you know, we have data in every cell, right? So these data are called domain. So the domain, okay, the domain is the allowed value. I'll write it down. Is the allowed value for each attribute. Okay, so for example, in the ID, what's the allowed value? Is it a string? Is it integer? What can I put in the ID column? Right. So this is called a domain. It's an allowed value for each attribute. So the domains are actually in the cells. Okay, it's the type of what you can put in your cell. What data can you put in your cell? Also, we have another terminology in the relational. Maybe it's not very related to what I've just said, but we have something called atomic. Also crops up at the beginning of the chapter. Atomic. Oops. Okay. Atomic. What's an atomic? It's also an important terminology. Is the value that can or actually that are, or that is. So atomic is the value that is indivisible. Indivisible. What does this mean? Right. Right. Consider this. If we right, let's say if we take this example, write it maybe in red. Okay. If we have, for example, our course code is IT244. Now, this value is not atomic. Why? Because it's divisible. Now, the atomic must be indivisible. This code is actually divisible. Why? It's made up of two meaningful sections, right? We have IT refers to the information technology department, so meaning that this course belongs to the IT department and its code is 244, right? Combining together, it's IT244. So this is not atomic value because it is divisible. It is divided into two, and that does not fulfill the requirement of the atomic. So the atomic, you need to know this very well. Atomic is the value that is indivisible, cannot be divided into two, right? Okay. Also, we have keys. Okay, very important. I think we discussed the keys very well in more than one occasion. We studied four types of keys. We have the primary. We have the primary key. This is the well-known key. It's the strongest key. It's a unique key. Okay, for example, student ID. For example, student ID. It's a primary key. Why? Because there are no two students in the same university that have exactly the same ID. So in our university, every student has his or her own ID that identify the student. Okay, so it's a primary key. It's a unique for the student, right? So that's easy. Also, we have a super key. Okay, we have a super key. Now the super key is a key that is sufficient to identify tuples, sufficient to identify a record. Again, another terminology for the tuple is a record, and another terminology for the attribute is the field or a field. But obviously, in our course, we use the words attribute and tuple. Now, so the super key it's a key that is sufficient to identify tuples. For example, ID. Okay, ID can be a super key because it can identify a tuple with the name. Maybe the name it can also be used as a super key. For example, let's say in a classroom there's someone called Khalid, and maybe he's the only Khalid in the class, so he's a super key, right? Because in that classroom he can be identified by his name because there's no one else called Khalid in the classroom. But if we come to the university, this may not apply because surely in the university there will be more than one Khalid in the university, right? So this super key will no longer be valid. But within the classroom, within the table, this name can be used as identification as well. Okay, so that's a super key. Also, we have a candidate key. Candidate key. Candidate means مرشح. It can be a key, and it's a subset of the super key. Okay, the candidate key is a subset of the super key. So in a table, for example, in a table, Just let me use a different color. In a table, for example, you may have either student ID. Okay, you may have a student ID. You may have first name. You may have a last name. Okay, you may have a session. Okay, so every one of them could be a key again if it can identify a tuple, right? So it's every one of them is مرشح to be a key. Okay. Lastly, we also talked about the foreign key. Foreign key. The foreign key is a value in one relation that appears in another relation as a key. Now, for example, if we consider the just this previous example, now this session, it's not a key in here, right? But it may become a key in another table, right? So, for example, if we have another table that has, for example, a session and a room, for example, obviously, as you know, in IT244, we have so many sessions, right? So, and every session is allocated a room, a classroom, right? Now, this session here is a key, right? So, it's a foreign key, it's brought from this table here, right, to become a key in this table. So now the session identifies the room. Okay, so it's a key in here. So that's a foreign key. It's brought up from another table. Okay, so these are the 4 keys, which are also important to know. Now also, I think, well, something important that we also need to know is the difference between procedural and also non-procedural languages. Okay, we need to know the difference between the procedural and non-procedural languages. Now, the procedural languages and the procedural specify the operations. Okay, the procedural specify the operations to be performed on the data and the sequence of operations. So it tells you everything. It tells you everything on how you get the result. So you have operations in your database, and then you get the result. The procedural language will specify all the operations, the sequence, and everything you need to know in order to get that data. Unlike the non-procedural language is that it specifies only the results. Specifies only the result. The result. Okay, without referring to the operations. Okay, so it just specifies the result without telling you how you obtain this result. So this is the difference between procedural and non-procedural languages. Right. Also, it's very important the last set of slides of week 3 and 4, excuse me, is I think from maybe slide 10 onwards. The chapter talks about the relations, and it is very important. You will get asked about the relations in more than maybe one question, right? So you will need to know them. Now I will quickly go through them without the need to explain. We have obviously, as you know, we have examples at the end of the chapter where it explains every relation, but um, I will not go through that because obviously I think I personally I think explained them more than twice or 3 times. So I will not explain them again in here. I think I even explained them in the last mid-term revision. I don't know if you, obviously my students can get access to that because it's on Blackboard. I don't know about the other students, but anyway, you have been taught these very well. So I will not go into explanation. The reason is because you will not get these examples that you see in this chapter of the relations. You will not get asked about these examples specifically, but you will get asked harder ones. Okay, so that's some good news for you. You will get asked harder ones, just like what happened in the midterm examination. You had some, I think, tables or something like that, and you were asked to find the relations using algebra expressions. You will get something similar, right? You will be asked algebra expressions. So I will actually, later on, when I think we will come to talk about this, I think in further detail. So I think what I will do, I will solve the midterm question for you. So I think this will give a good example without the need to refer to these examples. But for you, you need to understand the examples are set in this chapter, because if you understand them, it may make things easier for you, right? So you will need to understand them. I think I explained them so many times. If you do have a problem, my students, you can refer back, excuse me, to the midterm revision. I think I explained them in the midterm revision, so you can refer back to that. And for the other students, you can refer to your instructor to explain this to you if you do not understand them. But I think they're very easy to understand. Anyway, what I will do, I'll go quickly through the operations and just remind you of their importance as well. So the first operation we have is the select operation. Select operation. All the symbols that are in these relations are very important because you may get asked these in the multiple choice or true or false or whatever, right? Or fill in the blanks. You may get asked these to write the symbols, and also when you come to write the algebra expressions, as we will see later, when you produce the algebra expression, you will need to use the symbols, right? So it is very important to understand the symbols as well and understand the operation. The select we refer to using the sigma symbol. So remember this, right? And that's the first thing. Again, I don't need to give the example because it's there for you. I will just repeat the same example. So just it's there for you. You can go refer to them, but it's very important that you understand. This is a very important topic, right? Also, we have the projection. And for the projection, we use the symbol pi. Right? I always, I say to my students that selection normally deals with the tuples, with rows. So I just to remind you, I say, okay, then imagine this, right, referring to the tuple, right? Just like as if this is referring to a row. While the projection deals normally with the columns, right? So imagine these being like pointing to the columns. Okay, these pointing to the columns. So just this is a way of maybe just to remind yourselves on what these symbols mean. So the sigma is for the select operation, and the projection uses the pi symbol. Also, we have joining of two relations. Joining, I'll write it here, joining of two relations as if you are multiplying. Okay, so if we have two tables that are R and S, and you are asked to join the relation, you will use this symbol, the multiplication symbol. So this is for joining the tables, and also just joining, and also we have the union of two tables. Union of two tables, and obviously I'm sure you all know the symbol of the union. It's U, right? So we have the union of the two tables, or more than two tables. So this is you can use U. We have difference. Difference as if you are saying subtraction. Okay, so difference as if it's a subtraction. So when you take the difference between two tables, for example, if we also have table R and S, and you are asked to find the difference between them, so the symbol is, so if we have R and S, two tables, the symbol for the difference, as you know, is the subtraction symbol, right? So this is the symbol for the difference between two relations, or more than two relations. We have intersection. Okay, we have intersection. Intersection, and from mathematics, we all studied the intersection to use the symbol like I don't know. It's upside down of the union. It's like a U upside down. That's the intersection of two relations or two tables. Last thing I think we came across, I think it's the natural join. Okay, the natural join. Natural join. It uses this symbol. It's the multiplication, and it has like the absolute. Well, that's not the best, drawing, but I'll try again. Okay, something like that. That's the natural join, right? Again, very important that you make yourself familiar with these symbols and the understanding of each one of them. We have selection, projection, joining, union, difference, intersection, and natural join. You need to understand what they mean, how to apply them, and what the symbols they actually use. Okay, so that's it for this part. We've covered week 3 and 4, and just another short break, and I'll be back for part 3. Okay, so I'll see you then.